Okay, here we go. I'm doing this at home because I forgot to hit the record button during class today, so I apologize for that. If you do run into any issues, send me a chat. Here we go. All right, any questions on the homework? Any questions on, well, I'm not sure what I'm asking you. It's not live. So let's go to the calendar. Let's see. We're going to do 5 sections in total for this one, plus 3 days of graphing something called quadratics. We'll take a quiz on Thursday. The quiz will be on, obviously, sections 1, 2, and 3. This chapter is the last one that we'll do. It's the last one in the book. We will literally end on the day we're supposed to end, and then we'll jump in on semester finals. Excuse me. And then the last week, which is not shown here, you'll see it next week on the calendar, is the semester final week, and we're done. Here's your homework. I'm going to warn you, this is a hard one. This is a very challenging one today. Okay, since we're not live, if you do need to pause at any time. But I'm going to go through this as since it's not a live class. All right, the lesson's called Completing the Square. This strikes fear in the hearts of most math students. Well, oh, completing the square. And it's more so because it is a challenging procedure. Kids remember that it had a lot of steps. It was a little complicated, but I will say, once you understand what's going on, it's not as bad as people make out. I think half the time people make it out as being bad because, one, we don't use it too often. And then two, because we don't use it that often, you immediately forget it. Then you're taught this, 3 or 4 times. I'll teach it to you again when we get to geometry, and then you'll get it again when you get algebra 2, and then you'll get it again in pre-calculus. They won't teach it to you in calculus, but you kind of see what I'm saying is that we use it infrequently enough that it has to be retaught. And I think that's why it gets a reputation as being a very challenging thing. But I won't lie to you. This is certainly it's the most challenging thing that we'll do this year. All right, so it's the most challenging class. So, put on your big boy, big girl pants. Here we go. All right, recall. Recall that we have solved quadratics before, and the way that we did it, this way back second quarter, the way that we solved them was that we factored. And if I ask you right now how many people remember doing this, everyone will say, yeah, I kind of remember. But if I ask you to do it, maybe half of you might remember literally how to do it. So let's recall how we do this. So to solve a quadratic, well, first off, let's see why it's called a quadratic. It's called a quadratic because the x value is squared. Remember, when the x value is to the first power, for instance, I don't know, 2x plus 1 is equal to 5. We call that a linear equation. It's a linear because x is to the first power. Quadratics are called quadratics because the x is to the second power. Okay, or the highest power of the variable is to the second power. It's called a quadratic. Further, this is called a trinomial because there's 1, 2, 3 terms. So this is a quadratic trinomial, and we have solved this very one before. So let's see if we remember how to solve it. To solve a quadratic trinomial, you would ask yourself 2 questions. And the 2 questions are, what 2 numbers, and we're talking integers, not decimals, what 2 integers multiply to 3 that add up to 1? Well, let's see, we consider all the possibilities. Let's see, 1 times 3 is 3, and what's 1 plus, oh, it's 4, and you just found the answers. So what do I mean by you found the answers of factoring is that these values right here, whether they're positive or negative, are what you plug in to the 2 parentheses. Remember doing this? Turns out that it factors into a binomial times a binomial, and the 2 values, by 2 values I mean this value and this value, the 2 values are indicated by the 2 numbers that multiply to this value that add up to this value. All right, do I need to prove that too? Sure. Let's see, let's just multiply them out. You can either use the distributive property, or I like to stack them. So if we stack them and multiply, let's see, 3 times 1 is a plus 3. 3 times x is a plus 3x. 1 times x is a plus 1x, right? X times 1, and then x times x is x squared. When we add all those up together, we get what? X squared is just x squared. 1x and 3x is plus 4x, and we got a plus 3. So it does work. Okay, so cool. We factored it. Great. Now what? Well, if you recall, let me look at what we literally have here. If you can imagine this whole thing is just one number, right? something x plus something is that x plus 1 is a value. And we got another value right here in parentheses, and the two are being multiplied together. I should put a dot, not an x, right? The two are being multiplied together. What's underlined is multiplied by what's underlined. Look at the answer. The answer is 0. That only happens one of two ways. Either the first thing that I underlined is equal to 0, or the second thing is equal to 0. Looks like I'm making a skateboard. Or they're both equal to 0. That process is called the zero product property, which says that if the answer to two things being multiplied is 0, either the first thing is equal to 0, or the second thing. Well, that's literally what I'm writing right there. The first thing equal to 0, or the second thing equals to 0. And then we solve that, each one individually. So subtract 1 from the top one, subtract 3 from the second one, and we get either -3 or -1. Those are the two possibilities. And we can plug those values in. We can plug those two values in and notice that it works. Let's see, we plug in -3. -3 squared is 9. -3 times a +4 is -12. 9 minus 12 is 3, and I'm sorry, -3, and -3 plus 3 is 0. It also works for -1. -1 squared is 1. 4 times -1 is -4. And let's see, -4, I'm sorry, 1 minus 4 is -3, and -3 plus 3 is 0. So those are your two values. Works great, doesn't it? When it's factorable. Let's do another one. Remember, trinomial, quadratic, factoring. We're looking for two numbers that multiply to 6 that add to 5. Haley's sending me a message right now. Okay. Let's see. 1 times 6 is 6, but 1 plus 6 is 7, so that didn't work. How about 2 and 3? 2 times 3 is 6. Oh yeah, and 2 plus 3 is 5. That works. So what I'm going to plug into my two parentheses are a +2 and a +3. And it doesn't matter the order that you write those. Cool. Zero product property. That means either this thing is equal to 0 or this thing is equal to 0. So you set both of them equal to 0 and solve. Subtract 2 and subtract 3. We get -2 and -3. It's customary to write the smallest one first. One last one, maybe? All right, let's look at one where we got some negatives involved, because all of these had positives. All right, here we go. Here we got a negative involved. So two numbers multiplied to -8 that add up to +2. Well, 1 and -8, well, that's what, -7. How about -1 and a +8? Well, that's +7. Well, how about a 2 and a 4, right? One of those will work, 2 or 4. So which one has to be negative to get to +2? Well, if the 2 is negative, all right, that gives me -2 times 4 is -8, and 4 minus 2 is 2. So those are the ones I want to use, right? I want to use -2 and +4. I'm trying to draw here. There we go. So I want to use x minus 2 and x plus 4. So x minus 2 and x plus 4. Set both of those equal to 0 and solve. Let's see. Subtract 4, that gives me -4. Add 2, that gives me +2. Very nice, right? By the way, this was the second quarter when we did all this. And when we got to one that wasn't factorable, we said, well, it's not factorable. We can't solve it. And that was true in second quarter. It's not true now. So the big but is sometimes you can get quadratic trinomials that are not factorable. And check it out. There are no two numbers that multiply to -4 that add to +4. Okay, so that's our problem. There are no numbers. I can plug in. I can think, till the cows come in, I can plug in numbers and it won't work. Okay, so, well, a long time ago, mathematicians came up with a solution to this, and that's what today's class. So that's like a 10-minute wind up to what today's class is on. So this is the part that will be challenging. Okay, so you got to stay with me. Now I'm going to fill this whole slide up with calculations. Don't panic, right? So I'm going to select 3 trinomial quadratics. So they're all trinomials. They have 3 terms, and they're all quadratic, x is to the second power. All right, well, let's factor each one of these. Okay, so the first one, what multiplied 9 adds up to 6? What, that's a 3, right? And then it's x plus 3. So I could rewrite that as x plus, if there's 2 of them, I could write that as x plus 3 squared, because there's 2 of them. Let's look at the second one. Two numbers multiply 16, add up to 8. That's 4, right? 4 times 4 is 16. 4 plus 4 is 8. All right, so I can write that as x plus 4, x plus 4. Well, that's just x plus 4 squared. Why did you just go away? There we go. And the last one, two numbers multiplied, 25, add up to 10. Well, hopefully you see the pattern here. Well, that would be 5, right? Now, these are a special kind of trinomials. They are called perfect square trinomials. We talked about this earlier. Why? Because this value right here is a perfect square, right? Perfect square, 9, 16, 25. Well, that doesn't happen all the time. It happens very infrequently. But when it does, ooh, we can use that to our benefit because it's very easy to factor. All right, switch gears slightly. All right, I'm going to look at this line and I'm going to ask you to think about that line and the bottom line there in blue, right? I also want you to think about the numbers that start each one of those terms. In other words, well, the A term, there's no number here, so the A would be 1 in each case. The B would be what, 6, 8, and 10. And the C term would be 9, 16, and 12. I'm just asking to look at those numbers. I'm going to call the first one attached to x squared A, the next one attached to the x value, the B value, and then the last one, the C value, okay? Further, right, I'm going to make the following claim that if you start with what's in red there, that red line, those are perfect square trinomials, that its factored form will always look like this. I take the B value and I just simply divide it by 2, right? Do you see the pattern there? In factored form, each time it's just the B value divided by 2. I took 6 divided by 2, it's 3. I took 8 divided by 2, it's 4. I took 10 divided by 2, it's 5. I mean, there's another pattern there too, as well. Square root of 9, square root of 16. But I'm going to choose to write the B value. You're going to see why I'm doing this at the very end. Okay, so its factored form for any perfect square trinomial will be x plus b divided by 2 quantity squared. So that b value is the number attached to x. Cool. Well, that's the pattern. Well, there's absolutely another pattern going on here as well, too. So here's what we're going to look at now. We're going to look at its unfactored form. That's the top form. So the unfactored form, that's the top one there where the arrows are coming from. Check this out. This is pretty slick. Could be, instead of written this, instead of written the original way, I could write it like this. Well, the relationship between the b and the c is, well, c is actually b divided by 2 squared. Do you see that? C is actually b. Divide that by 2. 6 divided by 2 is 3, and then square it, you get 9. C is actually the b value. 8 divided by 4 is 2. 8 divided by 2 is 4. And 4 squared is 6. It's just b divided by 2 squared. 10 divided by 2 is 5. 5 squared is 25. So we can write the unfactored form without even using c. All right, that's a nifty trick. Why would I care and why would I do that? Well, remember our original problem. Our original problem was I can't factor it. There was something wrong with that c number, right? It was a -1 and there weren't two numbers multiplied, they're 4. If I could somehow change that c value to a new value to where I could get to the b value, life would be grand. And that's what this is all about. What this is all about is to somehow rewrite it and plug it in a new c. So here's what I need you to do. Everything in yellow and red, or you see the 2 yellow there's and what's in between is red. I need you to write that down. So basically I need you to write with factored form and the unfactored form. But remember, this says if you start with a perfect square trinomial. Hint, 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 we're going to be creating perfect square trinomials. We're not going to start with perfect square trinomials. We're going to make perfect square trinomials. Because if we have a perfect square trinomial, it is relatively easy to factor it. And by the way, look at the factored form. Doesn't that kind of look like what homework was last night? The answer to that is yes. And that's why this one follows the previous night's homework. Okay, so once again, this isn't live, so if you need more time to write it down, pause and then rejoin me. Okay, we are going to do 3 to 4 of these. So it's going to look like magic the first time, but it ain't magic. All right, so here we go. So remember our problem was it's not factorable because there aren't two numbers multiplied -1 that add up to 4. We're just going to get rid of this thing. In other words, we're going to erase it and we're going to make the perfect value for this. We're going to make a new C value. We're going to make, literally, we're going to make a new C value. Why am I allowed to do this? Well, you're going to watch. I'm not going to ever violate any algebra principles. Okay. So notice what I put on the top here. This is just so we can visualize what we need to do. All right. And here are the steps. Step number 1, C was the problem, get rid of it. Well, in algebra, you're allowed to do anything to both sides or anything to the equation as long as you do it to both sides. Guess what I'm going to choose to do? I'm going to add 1 to both sides. By adding 1 to both sides, I effectively get rid of the -1, which was causing us problems. So I'm going to add 1 to both sides. Do you see what I did? Now you wait a minute, I don't have a C value. So I'm going to make a new C value. And the reason why I can make a C value is because in algebra, you can do anything you want as long as you do it to both sides. So I'm going to make the perfect C value. What's the perfect C value? It's written right here. This is the perfect C value. This is also why we rewrote the unfactored form and we didn't write it with a C. Because it's with a B, and I know what B is. Guess what? B is 4. And what does that say in red there? It says take B. B is not 4x. B is just 4. So I just take the 4, divide that by 2, and square it. Well, 4 divided by 2 is 2. 2 squared is 4. Coincidence that it's the same number. So 4 is what I want my new C value. So how do I make my C value? I want that 4 to be right smack there. Well, I just add 4 to both sides of the equation. Think about that. If I add 4 to both sides of the equation, well, that's how I get a +4 there. I have to erase all that scribbling. So I'm going to add 4 to both sides. Look, now I have the perfect C. Now it's a perfect square trinomial. I've made a perfect square trinomial. 1 + 4 is 5. I can simplify that. 1 + 4 is 5. Now I have a perfect square trinomial. I can factor it. And life is even better because I already know what the factored form. I don't need to think about it. The factored form is x plus b divided by 2. B is 4. 4 divided by 2 is 2. So I already know it's factored form. It's that right there. Now be careful. It says x plus, right? It could be x minus, right? If b is negative and you divide, -10 divided by 2, you get -5. So it could be plus or minus. In this case, it's plus. Now, why did I do all of this? It seems like a whole lot of work. Well, look at what the equation now looks like. It looks exactly like last night's homework. You solved this last night. How did you solve it? You get rid of squaring by taking the square root of both sides. Remember, when you take the square root of a variable, you have to consider the positive and the negative answer. So we get x plus 2 quantity squared, take the square root of it, is equal to plus or minus the square root of 5. All right, one change from last night's homework. Last night's homework, you would have left that as the square root of 5. Tonight, they want a decimal approximation. So x plus 2, why is it x plus 2? Because remember, we took the square root, so it got rid of the square. So we want to write the two equations. Well, the square root of 5 is about 2.24. So if you get down to a square root, then yank your calculator out and do it. Subtract 2 from both sides. That's how we solve both equations there. So we get -4.24 and 0.24. Do you see where I'm getting? I'm just subtracting 2 from both sides. Wow, that was a whole lot of work. And yes, completing the square is a lot of work. Not impossible. We're going to do about 4 more examples. Okay, on to the next one. All right, so here we go. Procedures start with getting rid of the original C. The original C is -16. How do you get rid of -16? You add 16 to both sides. You get rid of subtraction by addition. You get rid of addition by subtraction. So I'm going to add 16 to both sides. I get that. I'm going to make a new C value, right? The new C value is found right here that I'm circling. It says take the original B value. The original B value is what? 6. Divide that, but it's not 6x, but just 6. Take that B value, divide it by 2, and square it. So 6 divided by 2 is 3. 3 squared is 9. 9 is what I'm going to add to both sides. 9 is my new C value. I add it to both sides. Why do I do this? Because I just made a perfect square trinomial. 16 plus 9 is 25. A perfect square trinomial is factorable. The original one may or may not have been factorable, right? So this right here, cool. B divided by 2, remember B was the value 6, 6 divided by 2 is 3. So its factored form would be x plus 3. I got the 3 from the B is 6, 6 divided by 2. Now it looks like last night's homework. Ooh, look, on the other side is a perfect square at 25. We can take the square root of that. Take the square root of both sides, so we get x plus 3 is equal to plus or minus root 25, which is 5. So my two equation would be x plus 3 is equal to negative 5, and x plus 3 is equal to positive 5. Subtract 3 from both sides. Subtract 3, we get negative 8 and what, 2? Negative 8 and 2, negative 8 and 2. And that is how it's done. Okay. If you are lost at this point, I would rewind and watch the two examples again. I would watch those two examples again until it starts to click. If it's clicking already, we're ready to move on, right? Let's do it one more time. This is the last easy one, by the way. All right, so procedure number 1, we get rid of the old c. The old c is negative 20. To get rid of negative 20, we add 20 to both sides. So I add 20 to both sides. I find my new c. My new c is right here. You take the original b. The original b is, be careful, it's not 8, it's negative 8. So the original b value was negative 8. Negative 8 divided by 2 is negative 4. Negative 4 squared is positive 16. So I'm going to add 16 to both sides. That's my new c value. 20 plus 16, 36. I have a perfect square trinomial now. Perfect square trinomial. That's factorable. It factors to this right here. Now you can see why I put those on the top. So it's x plus b over 2. B is, be careful, not 8, it's negative 8. Negative 8 divided by 2 is negative 4. Negative 4. Sweet, this is an easy one. Take the square root of both sides. Square root of 36 is 6. Remember, don't forget it's plus or minus. So we get x minus 4, not x plus 4, but x minus 4 is equal to plus or minus 6. So x minus 4 is equal to negative 6. X minus 4 is equal to positive 6. Looks like we're adding 4 to both sides. Add 4, we get negative 2 and 10. Once again, if this is clicking, you're ready to move on. If it's not, rewind. Do not go past box 4 until this starts to make sense. If it makes sense, you're ready to do a really messed up one. All right, so here we go. Really messed up one. All right, watch what happens. Step number 1, get rid of c. Right, and this isn't messed up because c is a really, really big honking number. You'll see why it's messed up here in a second. So we add 144 to both sides. So far, so good, right? No big deal. Check out the b term. It's not even, it's odd. Ooh. Why does that make our life horrible? Because if it's odd, we got to divide it by 2 and square it. Remember, my new c value is b divided by 2 squared. So I take 7 and I divide it by 2, and then I square it. You're like, well, that's not too bad. Well, maybe. Depends on your thought process of whether you consider 49 over 4 easy or hard. Yeah, 49 over 4, don't change it to a decimal. 49 over 4 is what you need to add to both sides. 7 divided by 2 is 7 over 2 squared, 49/4. Ooh, why does that make my life challenging? Because, well, I got to add 144 and 49/4. So I need common denominators. 144 over 1. I need to add 49/4. Common denominator would be 4, so I need to multiply that left term by 4. So 4 times 4 is 16, carry my 1, carry your 1. 576 over 4. I did that very quickly, but trust me, that's correct. Plus 49 over 4. And that equals 5? Yeah. 625. 625 over 4. 625 over 4. That was a lot of, this is why this is ugly. Just the numbers are ugly. Don't panic, even though you have fractions here. Life is still grand. It's easy to factor. Why? Factored form is just b divided by 2. B was 7, so factored form is no big deal. It's 7 over 2. Take the square root of both sides, and that's where you're really probably panicking. Turns out the square root of 625 is 25. Square root of 4 is 2, so we get 25. I got to erase some things here. Square root of 625 is 25. The square root of 4 is 2, so we get 25 over 2. Remember, that would be plus or minus. Look what happened. Look, we got common denominators here without doing any work. This will always happen, by the way. So when you subtract 7 over 2 from both sides, it's not as bad as it looks, right? So the two equations, we're going to subtract 7 over, look, we already got common denominators. Negative 25 minus 7 is negative 32. Negative 32 divided by 2 is negative 16. And on the other side, when we subtract 7 from 25, we get 18. 18 divided by 2 is 9. This one is, well, okay, I'm not going to argue that it's really fun and friendly, but it wasn't that bad. It just had really ugly numbers. Why did it have ugly numbers? Because look what's circled there in red. It's an odd number. Anytime you have an odd number for B term, it turns into pain. So we'll do one more, right? This is kind of medium pain, and then we'll call it a day here. You should be pretty comfortable with the procedure. Procedure is you move C, so we're going to add 19 to both sides. We got to make our new C value, or our new C value is B divided by 2 squared. B is 5. So 5 divided by 2 squared. Well, that's not bad. That's what, 25 over 4. All right, that's what I got to add to both sides. So B divided by 2, 5 divided by 2 squared is 25 fourths. So I'm going to add 25 fourths to both sides. This is just like a common denominator problem right here. So we get 19 over 1 plus 25 over 4. Yes, it'll seem like every single time the common denominator is 4. Why? Because when you divide by 2 and square it, you get 4. Well, let's see, 19 times 4, 6 carry your 3. We got what, 76 over 4 plus 25 over 4? Yeah. Let's see, 25 and 75 is 100, and it's just one more. So it's 101 over 4. So I need to add, and I get 101 over 4. All right, cool. I'm not panicking. Why? Because I know the factored form is right here. It's B divided by 2. B is 5, so it's 5 over 2. I am panicking now that I got to take the square root, right? I got to take the square root of 101, and there's no perfect squares in 101. So I'm grabbing my calculator. By the way, square root of 101 over 4 from last chapter, square root of 4 is 2. So we get the square root of 101 over, not 4, the square root of 4 is 2. I'm just going to grab my calculator. I'm going to do the square root of 101 divided by 2. And when I do that, well, yeah, I'm going to get a decimal approximation. Where's my mouse? I've lost my mouse. Oh, that's bad. I got to find it. There it is. I'm not sure why it decided to go missing there. So once again, when I plug this into my calculator, the square root of 101 divided by 2, I get about 5.02. 5.02, and we can take it from there. By the way, 5 over 2 is what, 2.5? Okay. Subtract 2.5 from both sides, and that's what we get. Okay. We did 5 of these. 5 of these. The first 3 were pretty easy. I would rewind the tape here and play those a bunch of times. I do want to point out tonight for homework, right? There will be some easy ones. Notice this is like question number 1. Notice they've already moved the C value, right? You don't need to move the C value. It's already been moved for you. You just need to find out what the new C value is. The new C value would be B divided by 2 squared. B divided by 2, negative 2 squared. Hey, the new B value is 4. So add 4 to both sides, and you're ready to rock from there. You also may get one that looks like this. Do not panic. It looks like it's going to be horrible because you got negative 175. No big deal, because the first thing you're going to do is you're going to get rid of negative 175 when you make your new C. You're going to add 175 to both sides. Don't panic. Okay. You might get some where it's not equal to 0, it's just equal to another number. No big deal. So the first step, add 2 to both sides. Don't panic because it doesn't say plus 0. Okay. There is one for homework where I'm going to make these numbers up. It says something like 2x squared plus 14x plus 10 is equal to 12. Notice we haven't done any one where a was not equal to 1, 1, 1. So the step here is, well, divide everything by 2 right from the start. If you divide everything, every term by 2, then a is equal to 1 and life is grand. Okay? So if we divide everything by 2, we get x squared plus 7x. Oh, it's going to be an ugly one because it's odd. Plus 5 is equal to 6, and you can take it from there. Subtract 5 from both sides, and away you go. All right, that is it for today. Remember, we love this when that middle term, the b term, is even. We hate it when that middle term is odd, right? So good luck. Send me chats if you run into any problems, right? And we will pick it up tomorrow where we left off. Enjoy your evening.